Hi everyone, my name is Wolfgang. I'm a PhD student at the University of Southern California, and I would like to start off by introducing you to the BitCraze Crazyfly 2.0, which is a super tiny nano quadcopter. It just weighs 27 grams and fits into the palm of your hand. It runs a fairly novel microcontroller, the STM32, has sensors on board and runs a real-time operating system. Now it's interesting for research because it has an expansion port allowing you to use it even without soldering, and it has a low latency radio where you can communicate with it in just 3 milliseconds. Next slide, please. Now that would be totally boring to you guys if you couldn't control it with ROS. So there's a ROS stack for it, and it comes with the batteries included, unlike some other packages. So it consists of an actual driver which communicates to the Crazyfly, and it supports multiple of them, and you can even use a single radio to control multiple of them. You can use one radio for 3 Crazyflies if you wish. It is very fast, written in C++, and it supports all the features of the Crazyfly, including locking and parameters. It works with the stock firmware. You can use Orbis to visualize your state. In the future, you might be able to do motion planning as well. And it comes with a controller. So if you have a motion capture space like Vicon, you can use that to do waypoint navigation, and it all works out of the box. And it includes demos using joystick navigation and waypoint navigation for that space. Next slide, please. Now, if you're wondering why does it make sense, I mean, that thing is so tiny, I have no idea what to do with it. You might be right. However, for every solution, there's a problem. So in that case, the problem is that we have this huge gap between simulation and implementation, and you can close that gap by using mixed reality and put parts of your system in the virtual world and parts of your system in the reality. And the Crazyfly is an ideal platform to do so, and I just published a paper with some colleagues at IROS before, which discusses that, and it uses ROS extensively in combination with various simulators like Gazebo, VRAP, and even the game engine Unity 3D. And if you're interested in that, please check the paper out, visit our website, act.usc.edu, and talk to me or send me an email. Thank you.
Thank you very much. We have Patrick up now and Laszlo on deck. Thanks.
Okay. Hi, my name is Patrick Wiesen. I'm from University of Applied Sciences in Aachen, and I'm here because I think ROS is awesome. And I think all of you is here because you agree to this. So our idea is with our ROS Summer School to spread ROS all over the world. And our ROS Summer School is an international 2-week event where people come really from all over the world and learn in 2 weeks how to use ROS, totally from the scratch. Next slide, please. Yeah, a little bit to our own history. We started in 2012 with around about 10 participants, and yeah, we are very happy that we could reach this year to serve over 60 participants. And yeah, we had also to lock the registration because yeah, we were totally sold out. And yeah, ROS Summer School is every year a big international event. This year we could serve 17 different nationalities. To visualize this a little better, maybe on the next slide we have yeah, a world map. So you see where people come from to visit our ROS Summer School. It's really not only Europe, so it's America, Asia, Australia, and Africa too. And next step we will do is also to export the ROS Summer School. We start next year in South Africa. And next slide. Yeah, there you see our robot. You can see here it also in real. This is our concept. So on this robot, usually groups of 3 participants work on one robot, and so our concept is hands-on hardware and learning ROS by doing. Therefore, we try to touch in the 2 weeks at least all topics from mobile robotics. And we prepared a little video to give you some impressions for that. So in the beginning you see a participant giving a little lightning talk. So now lightning talk in the lightning talk. And we have also always some guest lecturers and some people from industry there. For example, this year ClearPass and Zig. And here you see our hacking area, and I think now also some clips from our competition. One task is to teleoperate with an Oculus Rift through our paper world, and another task is then autonomously delivering pizza service. One last thing I want to mention is we also... Okay, thank you very much.
Sorry about cutting off there, but it was kind of ironic. All right, we have Laszlo up now and Yeet up next.
Thank you. Hello everyone, I'm Laszlo Nagy from the Norwegian company PPM. And sorry for the crippled presentation, you can download the whole version from the link below. We will see in a few minutes. And we are in the robotic and automatization world for more than 10 years now. And after some years, we just got bored of explaining the users, press the green button and then the white and then the red, and if it blinks, then blah, blah. So we just started to develop an easy to use and easy to develop user interface called FlexGUI. And the basic idea is that you just grab widgets on the screen, you can script it if you want, but you don't need to. And on the user side, you have no codes, nothing to remember, it's just images and buttons. And as you see, even a 10-year-old Japanese girl could get her cookie quite easily from an industrial robot. So, please slide. So on this way of thinking, we just redesigned how one should palletize. It's 100% touch-based, no coordinates, no coordinate geometry. And you can do a palletizing project in just 5 minutes if there are no errors, of course. Please slide. But we had a lot of criticism and also compliments. Why isn't FlexGUI running on all robots? So we just searched for the best middleware for Industry 4.0, and we found ROS to be the one. So we're developing FlexGUI 4.0 right now that runs 100% in JavaScript in the browser. So it runs on my phone, on the Ubuntu just as well, or on the robot controller. It will be released to open source, and we would like to join the ROS Industrial Consortium as well. Slides, please. And as you see, we are also working on the ROS drivers and the bridges. So now you see it's controlling and reading data from 2 turtles at the same time. But there are a lot of ways to improve it. So we would like to make better node survey and also show all the data types quite well. So it should be just as intuitive as without ROS. So just drag and drop stuff and look for stuff in a tree. So thank you for your attention, and then please don't hesitate to contact us. We are really open to suggestions and new ideas. Thank you.
Thank you. On deck is Carlos. We have Yeet coming up now.
Hello, everyone. I'm a master's student. Actually, I've just completed my master's at RWTH Aachen University. And I've been doing my master's thesis in collaboration with Bosch, also with Deep Field Robotics. So here's the real-time ROS framework for embedded systems. It's basically small embedded systems such as STM32 F4 Discovery, which I tested the framework with. So the framework was tested with FreeRTOS, and we can have multiple software components in the system that act concurrently. For instance, if we have a camera node, like you can see, and a motor controller at the same time. The scheduling behavior is important in order to guarantee real time in the system. So if we have a 1 millisecond deadline for the motor controller, then this deadline has to be guaranteed. For introducing this, I have implemented a deadline scheduling, and the whole framework also realizes ROS communication protocol, currently using UDP ROS 1.0, and I recently also tested free RTPS, with which you can program the ROS nodes very simply. As you can see in the next slide, it is like C++ in regular ROS on Linux, and it also allows you to specify the deadline or priority to guarantee real time in the nodes header. And in the next slide, I want to thank you, my supervisor, Dejan and Arne, for supporting me, and also my professors and supervisors at the university. So you can use the code on GitHub. It's publicly available. There's still some fixes to be done, which I will do in this month. After that, this code will probably not be maintained, but your collaboration will help on bringing this concept further. I think it will provide a lot of it will provide a lot of contribution to bring real-time properties to ROS, both 1.0 and 2.0. I want to thank you, thank OSRF and all the sponsors for organizing this event. And if you want to get more information, feel free to come to our Bosch booth in the coffee break. Afterwards, we'll be leaving. So thank you for your attention.
Most honest presentation ever. We have on deck, Carlos is presenting, and on deck is Robert.
Hello everybody, my name is Carlos. I'm application engineer from MathWorks headquarters in Natick, Massachusetts. And today I'm going to tell you the story in 3 minutes about the release of our new product, Robotic System Toolbox. When that slide comes up. Okay, next please. So our tools are widely used in industry. Next please. I'm going to show you an example. For example, NASA designs their control, navigation, and guidance system using model-based design, our modeling tools, and code generation technology. Next please. So we asked, how can we really help people doing robotics applications? We knew that we were already using our tools to develop very cool applications. So last year, we received like 2,500 requests, and they were asking for one thing. How can we communicate MATLAB Simulink to ROS? So we would like to make our customers happy, and that's why we released Robotic System Toolbox. Which the main features is that now you can connect MATLAB and Simulink to any ROS-enabled system, simulator, or real hardware, and you can be running MATLAB from Linux, Mac, or Windows. Besides that, if you're using Simulink, you can also generate automatically a ROS node using our coder technology as well. Next, please. So to show you some examples, you can see already some very advanced applications, for example, Baxter playing checkers, human-robot interaction. If you're using our computer vision tools, you can also do 3D reconstruction or visual odometry with our tools. So it depends on you. We give you the tools and you design any application that you want. And next, please. So we like to talk about impact. So in terms of impact, top of the automotive and aerodev companies, top 10, are already using our tools. You heard from Michael before, BMW is like happy customer that are leveraging our robotic system toolbox. And besides that, already 300 universities worldwide are using our toolbox. You know that MATLAB is already pretty popular among universities as well. So we're very happy with that. Our workshops at ICRA and IROS have had like more than 50 or 80 attendants, and all of our customers satisfied with the performance of our product. Next, please. In terms of why you can shorten your development time if you use MATLAB Simulink and Robotic System Toolbox, well, it's twofold. First, we're providing you MATLAB ease of use, right, with all the powerful tools that ROS has. And second, the toolbox also comes with built-in and fully qualified robotics algorithms, transformation functions, and, well, all other utilities. And finally, thank you for your attention.
Thank you. We've got Robert up now and Jinwook on deck.
Hi, my name is Robert Codd Downey from York University, and I'm here to talk about ROSCon, dynamic ROS-enabled, or dynamic control interfaces for ROS-enabled robots. Next slide. So, simple overview, we have an iPad running iOS, and we have a robot with ROS and ROS Bridge. Next slide. So there's two parts to this software. One is the ROS Bridge client library, which provides access to the ROS environment, the message passing architecture, and the servicing infrastructure. It provides dynamic class creation, so the memory footprint is only expanded on demand. It handles the networking, so if you have oversaturation of the bandwidth, it will automatically deal with that, so you no longer have that oversaturation, and it deals with link failure. This is important because you don't want to have to provide a full ROS environment on iOS because you can't. Next slide. The next part of this is ROSCon, which basically allows you to create interfaces to view camera data, view map data right on the device itself. It uses type introspection to allow you to use widgets with any compatible message type. So if you want to use a map widget, all you have to do is have any type that has a lat or long variable, and it can view that data. And it allows you to use the device's sensors and publish that to ROS, so you can publish your camera or accelerometer data right to ROS. So next slide, and there should be a video of this in action. So this is a sped up video showing that you can move widgets around. You can also create compound widgets to publish data from the accelerometer, the gyroscope, and attitude sensor to create a full sensor IMU message. And next slide. It can also run with TurtleSim because you need to have a turtle and a talk. We can also, as you can see, make a service request to initialize a new robot. Next slide. Here are some other UIs that have been created. One with map and an omnidirectional camera. It also provides canvases, which are sets of widgets. So you can have things like, I want to display all the sensor data from the left arm and have a separate camera for the right arm, and you can switch between those automatically. Next slide. Use cases for this, you can have collaborative interfaces. So if you have 5 people working in the field, you can share camera data from each of them and pass text messages back and forth to discuss who's controlling the robot at that time and what they need to do.
All right, Jinwook's up, and then Peter and Bert on deck. Jinwook from Robotis.
Thank you. Hello, everyone. My name is Jinwook from Robotics Company. I started 2002 as a robot soccer organizer, or robot soccer World Cup organizer, and happened to meet my CEO and joined this company in 2007. And my company is actually manufacturing the dynamic cell, which is the smart and modular actuator, which you normally use for the joint, such as pen tilt, manipulator, hexapod, and humanoid alike. So if you see some of them, that might be one of my cells. So yeah, here, yeah. But while I've been selling a lot of dynamic cells, I see something is difficult to share software because when people build robots, they are kind of competition. It was competition, and then also they want to stick to their own code to make their specific task complete. And sometimes they say making robot walking real time, ROS is too heavy. But over time, yeah, next slide. I found, yeah, computer is rapidly making evolution, and then also the community itself, the ROS community, is actually growing, and providing a very nice foundation of tools like Albiz and Gazebo, which we also used the ROS and Gazebo for DARPA challenge. So most of the people know Atlas is one of the good humanoid, but the previous slide shows that they actually use dynamics and more, 17 out of 23. So I was winning. And here, actually, I joined ROSCon first time, but I know Brian and Morgan quickly, and Tuli has been doing great. And we also want to contribute to the community, and I'm here to hear from you more about how we can collaborate more to build very nice community and to build a very reliable, modular, yet very helping to people. Thank you very much. Yeah, this is the slide. We did 2 days ago at ROS, and
On deck is Jeff, or Jeffrey.
Hi, I'm Peter from Intermodalics, that's Bert. We're getting 5 minutes because we had to merge 2 presentations, so it's 2 in 5 minutes. It's 2 totally different things. Okay, so the first thing is about oracles and ROS integration. So it's been mentioned in a lot of presentations. So I created oracles during my PhD, and I maintained it during 10 years, and around 2012 then the releases started being made by Intermodalics, by the team at Intermodalics, and we're still releasing it. We're releasing it through GitHub, but also since ROS Electric, we're releasing as ROS Ubuntu packages, and we're also in Indigo and Jade today. So you can find our software on GitHub, Oracle's toolchain, RTT. That's the real-time toolkit. That's the real-time stuff people are talking about. And there we are, version 2.8.1. But if you want to integrate with ROS, it's part of the Oracle's organization, and that's the RTT ROS integration. There we're at version 2.8.1. Next slide, please. So if we want to explain oracles before ROS existed, it was like this. You had these real-time components, and you could have log-free communication between them, and that could then communicate with your robot and so on. And that's run in the oracles deployer. Now, we were like using KST to plot things, and you know that software crashes a lot and so on. And then something fantastic happened. Next slide. We got ROS, and that really changed our ecosystem. We could publish everything in our real-time system to topics. We could monitor it using RViz. We could use ActionLib, dynamic reconfigure to set our parameters. It was really a nice thing to do. We used ROS launch, RViz, and so on. And that's really the nice thing there is that we only had to do this by loading a ROS service. And the introspection is really not disturbing your real time. Oh, it's already 3 minutes? Oh, no, 2 minutes. Yeah, next slide. Okay, so people ask us, what do you think about ROS 2.0? We think it's a great thing. We're happy that ROS is really expanding it, and it will also make it for Oracle's users easier to publish things on ROS. And of course, Oracle's RTT will remain ROS integrated also with ROS 2.0. In the maintainership, so Intermodalics will keep releasing the oracles, ROS integration, and so on. We depend a lot on it. And we will also redo oracles.org because the site is a bit dated, and we'll have better solutions there. Thank you.
Thank you, Peter. Hi, everyone. I'm Bert Wellert from Intermodalics, and I want to show you some of the cool applications we are doing with ROS and oracles today. So next slide, please. So oracles was the starting point of Intermodalics, but clearly today Intermodalics is bringing much more than oracles. So some figures. We started our commercial activities in Belgium in 2012, And over the last couple of months, we doubled the size of the company, and we are also hiring. Not 30 people, but we have multiple positions. And I would also like to point out that we are not backed up by any investors, which means that we can control our own strategy, and we enjoy that every day. Next slide, please. So I think we all know that robotics today is a very interdisciplinary field, and so we have different expertise in our company in motion planning, 3D vision, 3D navigation, and real-time control. And let's have a look at what we do with this expertise. So these are just some of the references where we can talk about. So we are supporting NASA in their efforts to control the RoboNode, as well as doing their satellite docking with Oracos. We brought ROS and Oracos into the ITER project, which is a global effort to make a fusion reactor in France. We are working with the Project Tango team to get 3D navigation and 3D reconstruction into tablets and smartphones in less than 2 years. And we also did a great project for Puy de Fou, which is a theme park in France. And we made all the software that controls a swarm of robots which fly fully autonomously from takeoff to landing. And they are holding these candles and puppets and ghosts, and so it's for a night show, and it's a very spectacular sight. And so sometimes people wonder, how can you do this with such a small company? And all these very different markets active, is that efficiently? Well, the answer is ROS. I'm sure that Intermodalics, I think it's fair to say, would not exist without ROS. So we really want to thank the community for that. Next slide, please. And so we have one more thing, apart from our project-based work, we also have our fixed-price product, which is called Picket. And Picket is a 3D vision solution that helps you to localize objects in bins, on pallets, and on conveyor belts. And so it comes with a ROS interface, so it's very easy for you to integrate it into your software projects. I would like to end by saying that we are here with the whole team. Okay, thank you.
Thank you very much. All right, we've got Jeffrey up now and Alex on deck. Pardon? 10, right? Yeah. Okay. Yep. Yep.
Right. Good afternoon. I'm Jeffrey from University of Tokyo. Okay. So today I would like to present you a very interesting topic that we have initiated in Japan. So as you can see here, the educational open platform for RoboCup at Home, which is actually a service robot development. And this is with ROS and Turtlebot 2. Okay, so our team participated in RoboCup at Home for many years, and we found that there's a few challenges that we would like to tackle. That's why we have initiated this project. So you can see like the motivation to build service robot is hard, okay? And high cost, manpower, and development time. So what we try to do is like we want to target an educational platform that can pull in more people to join, below 3,000 USD, and try to leverage ROS framework to make things easy. And also, we want to provide a basic development platform for everyone, even non-technical person, because in RoboCup at Home, not just technical person, but even people that are non-technical is allowed and also is invited to join. And lastly, for education. Next. Okay, so how we start off? We want to make it as low cost as possible so that we can have a very wide acceptance. So we start from Turtlebot. Turtlebot 2 is a very good platform that we start with, and from there we try to set the direction so that everyone can use it and everyone can top up from there and make it grow throughout the years. So these are some of the development that we have do. So from the original Turtlebot function, we try to improve. You can see like a new version up there with the elevated body that can actually grab something on normal table height, and so on. Right, next. Okay, so this is the outreach that so far for a year that we have achieved. You can see like it's very promising. So in Japan, we actually collaborate with Robot Store, RT Corporation, and we have conducted several workshops over there, you can see. It's very encouraging. We show ROS and also Turtlebot to all the non-technical person, and they can catch up very fast. And also under RSJ, Robotics Society of Japan, so we host some symposium. You can see the Intelligent Home Robotics Challenge. So that is a symposium that we discuss about this matter, and also we have a very lightweight competition. You can see like the small turtle bot is actually competing with the big guy over there. And also, because we want to encourage more and make it more standard, so we have the demo challenge in RoboCup Japan Open, and we are going to do it annually. And also we participate in the International RoboCup, and we get number 7 this year. Okay, next. Okay, so as promised, this is the open source details of our team, and we are getting a new domain and we are shifting it. We try to keep up with the new documentation as well. Anything, you can contact me, and thanks for all the support, and hopefully more people can join us. Thank you very much.
Thank you. Next up is Alex, and on deck is Andreas.
No, sorry.
Hello, I'm Alex Henning, and I'm from Fetch Robotics. As Melanie said, we're hiring, and today I'm going to talk to you about some tools for producing high quality ROS packages. So I'm just going to call some attention to some packages we use at Fetch. So one of the packages we use is ROSlint, and it's a tool that will check your code and call out areas where you don't follow the style guide and where you're likely making mistakes, so that you are not doing as well as you can. And it will check your Python files against the PEP8 standard, and it will check your C++ files against the using CPP-lint, which is the modified version for the Google style guide. And you can integrate it with your editor like Sublime or Emacs, so that it will give you actual real-time feedback as you're typing when you make a mistake. The other tool is Catkinlint, and it will check your package XML and your CMake lists, just like ROSlint will check Python and C++, and it will call out common mistakes that you make and give you errors and warnings where you're violating what you should do. And next slide. And on top of that, there's a Fetch Tools package that has some utilities, including FetchLint, which will run Catkinlint and ROSlint, so that you can check a package and get a quick overview of where you're violating things and really drive up the code quality. So we've been using these tools at Fetch, and we found them very helpful. And if you're developing ROS packages, they're worth looking at just to make sure you're following the style guide and have high quality packages.
Thank you. And I'm guessing you get them from those addresses, by the way. You forgot your robot. Next up is, so Andreas is coming up, and on deck is Shuo. Hey, Alex? I only have one. Do we have Andreas? Andreas. No, here. Oh, okay.
So I promised some general purpose tools beyond surgical robotics yesterday, and this is one I want to present. So it's called ARNI, it's Advanced ROS Network Introspection, also monitoring and automated countermeasures. Next slide, please. So ROS is great also for its introspection capabilities. However, they do not scale if you have a really large ROS setup. So if you have like 15 machines in your lab, all running on all cores and saturating 10 gigabit Ethernet, you might run into a bottleneck if you want to get an overview by subscribing to all ROS topics on a central machine. So what you can do, however, next slide please, is that you decentrally acquire all the metadata about all the connections going on in your ROS network. Next slide please. So since Indigo you can set a parameter on the server, and then each subscriber automatically publishes to the /statistics topic some meta information about the connections, traffic, frequency of packets, and so on and so forth. And they can be aggregated on the topics. Next slide, please. And we extended these capabilities for providing host-based and node-based statistics. You have to run one specific node on each host of your ROS setup, and that will provide you with all these additional metadata. Next slide, please. All these data get aggregated because it's only a small amount of data. So in our whole lab setup, it's like 100 kilobits per second. That's not a lot if you compare that to your use data, like that is gigabits per second. And all of this aggregated data is rated by our processing node, and you can specify what should be the case, on which topic should be, with which frequency and which bandwidth, what amount of data, at least or at most. And all this data is specified over a modular configuration that gets uploaded to the parameter server, and you can have orthogonal configurations. For example, one for your control, one for your sensor stack, and this does not interfere with the runtime flexibility of ROS. Next slide, please. And on top of that, we have the countermeasure nodes where you can use the rated data, which tells you, for example, oh, on this topic, the frequency of messages has fallen below the threshold you specified. And then you might want to restart the node or emergency stop the robot. And you can do that also with an orthogonally specifiable configuration that gets uploaded to the parameter server. Next slide, please. And then what you can use out of the box without starting any additional nodes if you're running ROS beyond Indigo, a GUI which gives you this central overview of all your nodes, all your hosts, nodes, topics and connections going on in your ROS network in one central RQT plugin, together with some nice historical plots about the data. Next slide, please. And with that, I thank you very much. It's documented more or less well in the ROS wiki, and I'm happy to answer all additional questions. Thank you.
Thank you. We've got Shuo up next and Robert on deck.
15.
There's a, yeah, we compressed.
Okay. Hello, everyone. It's my honor to be here to introduce our new product from DJI. How many of you have heard about DJI before? Wow, quite a lot. Thanks a lot. Thanks a lot. Initially, we're making ready-to-fly machines for normal customers who want to do aerial photography. And starting with this year, we make this new platform called Matrix 100. It is a special research tool for developers and researchers. The feature of this platform is it has an onboard API for people to send control command to the flight controller directly, and it has an extendable frame that you can mount your own equipment. As we've shown here, we mount a small onboard embedded computer, and we mount a set of sensors so that you can send in your control command from this small computer. So this whole system can work fully autonomously. And next slide, please. Since we want to make the system more integrated, so we developed our own version called Manifold. This is an NVIDIA TK1-based embedded computer. It has a close connection with our flight controller. It has built-in hardware connectors that allows you to directly connect to our flight controller. And it has the ability to read our gimbal stabilized camera from the system. This photo is taken during the IROS exhibition several days ago, showing that we have used our platform to read the camera image from the camera and display it as a conventional Linux machine. And you can use OpenCV to process the image and run your computer vision algorithms. And our system is built on ROS. You can have your ROS program to talk with our flight controller via our ROS package. Next slide, please. And there's already several researchers starting to use our system to do research. This video shown here is a professor who using our platform to do aggressive movement control in GPS-denied environment. Basically, the student from this professor use only 1 week to understand our system and start to know how to control it. And they use another week to port their algorithms onto our platform, and they use several weeks to write this paper, and it will be published soon, I think. So what we're providing here, we're providing a set of comprehensive programmable platform to allow you to use ROS to talk to a flight controller. And the whole system have open source, the protocol and the document all online on the GitHub. And the total price of this set of system is within $5,000 US. And you can get more information by visiting our website, dev.dji.com. And if you want to talk more in person, I will stay around for some time. And I will fly the drone above my head, so you can't miss me. Thanks a lot.
All right, and for our last lightning talk, we've got Robert.
Thank you. Hello, everybody. My name is Robert Rössler. I'm a research fellow at the Austrian Institute of Technology. It's the largest extramural research institute in Austria. Next slide, please. I will give you a short peek in our research in the area of autonomous land vehicles. We are developing a system, a modular and scalable system for retrofitting highly specialized vehicles. Like vehicles only existing several times on the world. And we developed a mapping system where we do the sensor fusion, so it's unimportant which kind of sensors you use. We have basically we have a stereo camera system, a laser system, and fused all the data into 3.5D representation of the world, of the environment of the robot. The map consists of an accessibility map, a height map, and occupancy map. The maps are stored in a GIS fashion, so it's stored in tiles, and it can be loaded it can be loaded from a GIS system and overlaid with satellite maps and viewed with Google Maps or something like that. In these cost maps, in these accessibility maps, we used OMPL to generate the local trajectory of the truck to avoid obstacles and to drive along a GPS path we defined in front of the mission in the GIS tool. Next slide, please. So these are my colleagues, and thank you for your attention. And please feel free to ask and contact us if you want to have further information. Thank you.